So today we're going to be working on split variables. And what this is going to be the third step up in solving any sort of equation. And now, one of the big things we want to point out is when two variables are on the same side, we combine them like normal. So if I have an x and an x both on the same side of the equation, I'm going to combine them differently than if they're on opposite sides. Because if they're on opposite sides, I have to move them across the equation by performing what we call inverse operations. And as we've seen over the past few videos, is we've worked our way up into more complicated equations. So let's take a look at what split variables look like in practice. So my first step is always to divide my equation into two sides. And what I notice is that both my x's, I can say they're not in one spot because I see them in two separate spots. So I'm going to have to combine them. Because they're both on the same side of the equal sign, I can look at this like an expression. What is 2x plus 2x? Well, that would be 4x. And boom, now I've combined them all in one spot. Now I move down my list of steps, isolating the term and isolating the variable like we've always done. I'm going to get rid of the 6 by subtracting it, which in essence helps me move it across the equal sign. And that's going to give me a 4x equals negative 8. And then in order to move this across the equal sign, I'm going to divide by 4, which is going to give me an x equals negative 2. And so we see the fact that if they're on the same side of the equal sign, it's not a big deal. You combine them, and then you solve the equation like we've been doing. So let's take a look at another one of these. First step is always divide the equation in two, and then take a look at where my variables are. They're both on the left side, which allows me to combine a 2 and a 1 to give me a 3x. Now, many of you might ask, well, how did you get 3x from a 2x and an x? Remember, when we don't see a coefficient, we always assume the coefficient is going to be a 1. So there's an invisible 1 just sitting right there in front. Our next step when isolating this is to get rid of the minus 10. And the way we undo minus 10 is by adding 10. That cancels out on the left-hand side. Again, keeping both sides of the equation balanced. 3x is equal to 21. Our last step is to get rid of the times 3, and we do that by dividing by 3. And 21 divided by 3 is going to give us an x equals 7. Cool. And so that works with variables. It also works with regular coefficients. If I notice that on the left-hand side of the equation I have an x term and an x term, separately I have some constant and another constant, or a number without a variable, I combine both of them individually. So my first step, if I want to do this the long way, is going to be to combine 10x and subtract 7x, which is going to give me a 3x. Plus 2 minus 1 is 40. Now I could do these at the same time. I'm breaking it up into two steps, so that way we can kind of see what we're doing. So a 2 minus 1 is going to give me just a regular old 1. What a lot of you might have done is you've combined the 10 and the minus 7 into a 3, and then you also combine the 2 and the 1 into a 1 all in one step, and you skip this middle step right here. From this point on, we just go ahead and solve the equation like we've been doing. Isolating the term, and then isolating the variable. And what that's going to give us is, in this case, x equals 13. Boom. Not bad. So what happens if instead of them both being on the same side of the equation, we have them on different sides? Well, remember, we're going to perform what we call inverse operations. Just like if I wanted to move this 15 to the other side, I would take the opposite of minus and I would add it. So the opposite of subtraction would be addition. So I'm going to do that same concept right here. If I want to move that 2x to the other side, well, that 2x is an assumed positive. So how do I get rid of a plus 2x? Well, subtract it. And what that does is that moves it to the other side, just like we would with a number. That's a negative 15 if you believe it. And then we go about solving the equation like we've been doing, isolating the term, and in this case, isolating the variable. In this case, we know a negative divided by a positive is going to give us a negative. So let's try that one more time, but instead of just with a variable, let's do that with, I have to move two things. First off, I want to move the 6x over. I'm going to do that by subtracting the 6x, just like I would any other term. And I get a 4x minus 10 is equal to negative 18. And if I move that over, now I got to move over the 10. And so we see how this is really the same process, just we're doing it with variables instead of just doing it with numbers, just doing it with the constants. So 4x. So if I have a negative 18 and a positive 10, one of the things I see is students will either say, well, that's negative 8, or they'll say that's negative 28. Now, remember what we're dealing with here. If the signs are different, I'm going to take the difference between 18 and 10. I know the difference between these two is going to be 8, and my 18's negative, so I'm going to keep the sign of the larger numbers. So negative 8. Now that I've isolated the term, I'm going to isolate the variable by dividing by 4, which is going to give me an x equals negative 2. Not bad. And so let's do one more. Let's throw in some negative signs just to make sure we've got the process down. But I think we've got it for today. First thing I'm going to do is I'm going to move one of these terms over. I'm going to move the 8x over. Now, I can explicitly see here, this is subtract 8x. Negative 8x, subtract 8x. The way that I get rid of subtraction is through addition. I'm just going to get rid of my 8x over there on the right. 8x minus 5x is going to give me a 3x. Then I go through the process of solving the equation by isolating the term, which is going to give me a 45 over here. Then my last step is always isolate the variable. We divide right down here because we know that 3 is connected via multiplication. The only way we can get rid of that is by division. Oh, and that's it. So today what we're going to be doing is we're going to be solving equations with parentheses. Now, we've finally worked our way all the way up to the first step in solving anything. We've been working with these n steps and slowly adding more and more steps on. This step is going to be the second to last. We're going to use distribution. Because if we have an equation with parentheses like this, we know that there's an understood multiplication. But not just with multiplication, we're going to have to use what we call distribution, which means we do multiplication many times over. And that basically means that whatever is immediately on the outside of the parentheses, in this case an x, is going to be multiplied by each term inside the parentheses. So that x gets multiplied times multiple things. And now, these first two examples that we're going to be working with can be solved two different ways. But I want to show you why distribution works, and we can check ourselves when we're done. So because the x is outside a set of parentheses, the parentheses are the first thing that I notice. I'm going to go ahead and I'm going to distribute that x times everything in the inside there. 2 gets multiplied by x and 5. So 2 times x and 5 times x equals 56. Should have drawn my line first. Now it's a little wiggly. And then in this case, just like what we did last time, I notice I have a 2x and a 5x on the same side of the equation, which give me a 7x. And then I go through the process like I've always done. I'm going to go ahead and isolate the term, which is already isolated. So then I go ahead and isolate the variable, which means I'm going to divide both sides by 7 because there's an understood multiplication. Whenever something's right up against something with no symbol, it's understood multiplication. So x is going to give me an 8. And now the reason why we set it up like this is so we could check ourselves is, does distribution work? Well, is there another way to solve this? Well, there is. 2 plus 5 equals 56. And now I set this up in such a way that we can check this equation. Most of the time, we're not going to be able to do what we're doing right here, but just to show you that this process works. Normally, I distribute, but let's go ahead and let's do order of operations first. 2 plus 5. That's going to give me a 7. And then whenever this is up against each other, I have a 7x. And then if I divide by 7, I get an x equals 8. Did we end up at the same answer? Yes. So does distribution work? Yes, it does. We just proved that it worked. So let's do another one just like this. Anytime I see a set of parentheses, my first thought is go ahead and distribute. So I'm going to distribute everything inside here gets multiplied by 4, which means that x gets multiplied by 4, and that x gets multiplied by 4. Again, I should have drawn my line first because it's going to be all wonky. And then the next thing I'm going to do is go ahead and combine my like terms. Because they're both on the same side of the equation, I'm just going to say 4 and 4 make 8. And then I'm going to go through the steps like we've always done, isolate the term and isolate the variable. The term is already isolated, so I'm going to go ahead and isolate the variable. Now, if I take 104 divided by 8, what I know is that 8 fits into 10 one time with 2 left over, 2 left over 4, 8 fits into 24 3 times. So x equals 13. And so let's check ourselves this one last time. Let's make sure that this actually works. So I have 4x plus x is 104. And what we notice is that x plus x is 2x. 4 times 2 is going to give me an 8. And if I divide both sides by 8, I get x equals 13. Did I get to the same answer? Yes. So we have proven yet again that whether there's numbers or whether there's variables, distribution works. So let's go ahead and do one where we can't prove that distribution works, because if we look at this one, we have an x and an 8. Those aren't like terms. I can't actually combine them like I did up here in my proof. So the only way that I'm going to be able to solve this is by distributing that 5. Now, yes, I know that some of you might say, well, there's another way and we could divide by that 5, but we're going to save that for a future lesson, namely when we go through the clearing of fractions. So I know there's a more advanced way to do this. We're going to stick with this method for right now. So 5 gets multiplied times x, and 5 gets multiplied times 8. So I get 5x equals 4, or so 5x plus 40 is 105. Then I go through my series of steps for isolating the term. I want to get my 5x alone. The opposite of plus 40 is minus 40. See, that gives me 65. Then I isolate my variable. The opposite of multiplication is division. And that's going to give me x equals, let's see, so 5 fits into 6 once with 1 left over. 5 fits into 15 3 times. Boom. And there we go. So that works nice and neat. But one of the questions you might ask is, does it always work the same with positives as it does with negatives? Yeah, it works pretty much the same way. So if you want to try a challenge, go ahead and try and pause the video and solve this equation, and then we're going to work through it together. Okay? So let's work through this one together. My first step is to distribute the negative 5 like I would distribute anything else. Everything inside the parentheses gets multiplied times that negative 5. So x times negative 5 is negative 5x. Negative 3 times negative 5 is positive 15. And then I go through my series of steps like I've always done by isolating the term. Cancels out that 15. And I'm left with negative 5x. And because I have 2 negative signs, remember we have 2 options. mostly what I see is students either go for negative 90 or negative 60. And the reason why they go for negative 60 is they think that 75 minus 15 is 60. But remember, these are both negative, so they're not going to take away from each other. They're not going to cancel each other out. They're going to add together and make a bigger negative number. So I get a negative 90 right here. So I've isolated my term. And in this case, I isolate my variable. Even though there's a negative out here, we still know that there's no sign between the x and the 5. I don't care what's going on the outside. I just care about what's going on between them. And I see nothing, so I assume multiplication. And the way that we do multiplication is, you guessed it, division. Negative negative is going to make a positive. 5 fits into 9 once with 4 left over. 4, 0. 5 fits into 5 fits into 40 8 times. Boom. There we go. And now if we see a question with, instead of just a single x, what happens if I have a coefficient? Again, nothing new is happening here. I'm going to go ahead and I'm going to distribute that 2 times everything inside the parentheses. 3x is multiplied by 2, 6x. 18 gets multiplied by 2, 36. And then once I've distributed, I go ahead and continue on isolating the term and isolating the variable. So isolate the term, get rid of that plus 36, minus 36. 2 negatives, as we just said earlier, up here, just make a bigger negative. It's a negative 48. Now that my term is isolated, I isolate my variable. Divide each side by 6, I get negative divided by positive is a negative 8. Perfect. And so let's do one more. Let's call this a challenge one. This one is no different than what we've had before. Just instead of having 1 parentheses, it has 2. So for the second time, I want you to pause the video, see if you can't knock these out, and when you're done, unpause it, and we'll walk through it together. Okay? Let's take a look at how we do it. Everything inside the parentheses is multiplied times 5. Everything in these parentheses is multiplied times 2. Now we can do this in 1 step or in 2. Because these are completely isolated from each other, we're going to go ahead and do this at the same time. So everything over here is multiplied times 5. 2x times 5 is 10x. Negative 4 times 5 is negative 20. Separately over here, 2x times 2 is 4x. 26 times 2 is 52. And so now, I notice that I have my x terms on opposite sides of the equation, so I'm going to need to move one of them over. And the only way I can do that is by balancing the equation and subtracting a 4x from both sides. Because if I take away a 4x over here, it goes away, and it in essence combines over here. Boom. And then I isolate my term, get rid of the minus 20. That goes away. 6x equals 72. And then I isolate my variable. Get rid of the times 6 by dividing by 6. So I get x equals, well, 6x and 7 once, 1 left over, 1, 2, 6 fits into 12, 2 times. Boom. And that's it.